Hey guys, welcome back to another video on the channel, and in this one I'm gonna go over the Inertial Confinement Fusion Reactor, something which I have covered previously in an updates video, but this time we are going to do it in more detail because there are new changes, like for example the pellet maker, which can make different fuel pellets with their respective values. They can be recycled now. Lasers now have definitive numbers and calculations attached to them, and I'm going to cover this all using the structure that I have made here. So without any further ado, let's get straight into it. So let's start with the empty ICF fuel pellet and the fuel pellet maker. So the fuel pellets will take 4 zirconium wires and 4 lead wires, and along with that the fuel pellet maker will take casted gold plates, some motors, and also a versatile circuit board. Now hovering over this will give us information about where the conveyor belts or the item pipes are gonna go, and if you take a look at the GUI, we have a place for muons, then left and right are for fuel, and in the middle we have empty ICF fuel pellets. So I'm gonna automate this for Deuterium-Tritium, which is a pretty simple process, as these are both fluid pipes. They can go on any side. And from the top, I'm going to input an empty ICF fuel pellets, and they will come out of the bottom using hoppers here. So automating this process is pretty simple. As for something which requires muon, you can automate it by entering muon from one of the sides, and once again the pellets can go on the top and come out of the bottom. So basically this can be automated pretty easily. Now we take a look at the different fuel types. Now all of them will actually end up in a common depleted ICF fuel pellet, no matter what type you use. But if you take a look closely, the heat required for each of the different type of fuel is different, and this heat will be supplied by a laser. So here I'm going to make a very simple laser with just one turbocharger, and it will supply us with 2.5 million thermal units of heat. Now this is not enough to power the Deuterium-Tritium fuel pellet. And this is why we need to calculate the amount of turbochargers and the capacitors required to make the laser, where the nuclear tech wiki comes in hand. So if we input the number of capacitors and turbochargers, it will give you the amount of power the laser will consume, and if you divide this number by 20, you will get the amount of heat that you are going to get. So I have noticed that using squares in capacitor, so 9, 16, 25 will give us an increment of 50 million HE per second. And using the same amount of turbochargers on the other hand will increase the, or basically multiply this power value by 3 times, thus increasing the heat value by 3 times as well. So here I have determined that 2 capacitors with 2 turbochargers is perfect for powering a deuterium-tritium fuel pellet. So 10.61, and this one requires only 10.5, and here we have a reaction going on, which can also be seen if we take a look at the lasers which are now active. So that is how you can calculate the amount of turbochargers and capacitors you will need in a laser. So basically this is the layout that I'm going with. For this reactor, we are going to have 2 lasers for fast depletion, but you can use only one of them if you want to, and this will be controlled via switches. So as I have determined, on one side each laser will have 2 turbochargers and 2 capacitors. So we have the laser cell with 2 flash tubes, on each side a capacitor and a turbocharger, and that's it. That's a laser done. Now you can make this horizontally, vertically, however you like, and make sure to cover them all with the laser casing. This is just like making a pressurized water reactor, because if you miss any block, then it will show you where you have made the mistake once you click on the laser controller. And this laser will output 10.61 million thermal units per second. So we make the other laser on the next side as well, and now we have 2 lasers which can be controlled individually. Now that they are not hovering in the air, I am going to use some scaffoldings, and yeah, the main thing here is the laser calculation. Basically what is the best way so you can use the minimum amount of power and get the reaction that you need to. So I'm going to connect both of these lasers using some cables here, and we will have redstone power switches to control them individually. We do the same on the other side, and powering these both will be one common power supply, which I'll place later on. Now if you're using just one laser, then you will only need 3 heat exchangers, but if you're using both the lasers, you will need 5 heat exchangers. So that is why I have placed 5 heat exchangers in total with industrial boilers on top of them. and all of these will be running on hot liquid sodium and liquid sodium cycle. So connecting the fluid ducts from the ICF reactor, on one side will be liquid sodium, so this one, once we connect it like this, and after 3 heat exchangers for the 4 and 5, place down a redstone fluid gauge, not the gauge, sorry, the valve in middle, so that we can cut off the remaining 2 heat exchangers if we are only using one laser, that is. And now this other side is for hot liquid sodium. So that's a liquid sodium done right here and hot liquid sodium here. And make sure to place down the redstone fluid valve. Then we can cover all of these pipes up. Also, I think in the new update you can use the grates as well for this. Anyways, connecting the heat exchanger, which I forgot, on both the sides for sodium and hot sodium. And next up, we set all of the heat exchangers for the maximum value, which is 24,000 millibuckets per tick. So hot liquid sodium with 24,000 set in the first slot. You'll only need a single Leviathan steam turbine, and we are going to run this on normal steam. And also don't forget to place down a redstone valve here as well, because if you are only going to use 3 boilers, then you won't need the remaining 2 boilers that are placed there. So once all of this is set, then we can place down the condenser, the powered condenser in this case. And using cooling towers would be like too much, because you will need 14 or 20 cooling towers, which is not really that effective. So powered condenser will work the best here. It will take away a lot of power that you produce, but then again it's worth it instead of using so many cooling towers. So connecting the powered condenser in the formation like this, set to water and low pressure steam. And once that's done, for the Leviathan, monitoring the Leviathan, I'm going to make a separate power source. Powering the lasers will be a different battery, and we are going to do the same for the powered condenser as well, so that calculations are a bit easier. We can just add them up and calculate them easily. Now setting up kinda the control panel. So redstone receivers on every redstone switch that we have placed, which includes the switches for lasers and also the switches for the sodium and steam. So in total we will have 6 redstone receiver torches, and here is an example of a very simple control panel with transmitters in the back, levers on the front, and on the top we will have some redstone lamps. Now don't forget to fill up all of the boilers with water and the ICF with liquid sodium. And once that is done, we are now ready to test our reactor. So we can turn it on by first supplying power, which will not go in because we have not turned on the levers yet. So first I click on the main power and then the laser 1. And this should start the reaction. The fuel that I have here is deuterium and tritium. It has started depleting, and as you can see, we are circulating just over 49,000 millibuckets per tick, which is exactly what 3 heat exchangers can easily handle. For the steam, we are producing a decent amount and we are getting 334 MHz per second of power, out of which the condenser and the lasers are consuming quite a bit, but we can take out the ratios later on. So now if I turn this off, then all of the liquid sodium will go back in. I'm going to turn on the fluid gauges, the fluid valve, sorry, I don't know why I keep on saying gauges. And now we can activate both of these lasers. So this time all 5 of the heat exchangers will be used because we are circulating 99,000 millibuckets per tick, for which you will need 5 in total. The power which we are producing has gone up, but so has the consumption. And as I will show you here, the ratio still remains the same. So this is the first case here in which we have the power produced over power consumed, and this is the second case. So nearly the same ratio we have been maintaining this. And once the fuel pellets have been depleted, they will give you, as I told you, the depleted fuel pellets, which can be recycled using a centrifuge and the fuel pellet maker. So in the centrifuge, you will get the empty fuel pellets back, which can be once again made into full fuel pellets, and this can be automated pretty easily. So if you enjoyed this, do like and subscribe for more videos like this. Peace out, my guys. I hope you stay safe.